Hello students. In the first part on differential equation, we had seen the order and degree and variable separable method. Then we saw the solution of homogeneous differential equations. In this video, we are going to see how to solve linear differential equations. And that also in just 3 steps. So watch the video till the end. First, what is a linear differential equation? If you are having a differential equation in the form dy by dx plus py is equal to q, where p and q can either be constants or they can be some functions of x, then it is called a linear differential equation of first order. For example, dy by dx plus y upon x is equal to 3x. Means over here your p, function p which is a function of x is 1 upon x. Same way q is also function of x which is 3x. You can have linear differential equation for any nth order also. Now, for example, if you are having a second order linear differential equation, it will be of the form d square y by dx square plus a, which is a function of x into dy by dx, plus b, which is a function of x into y, is equal to some another function of x. So, for example, if I have y double dash plus y dash minus 6y is equal to 0, it is called a second order linear differential equation. In this video, we are going to see how we can solve a first order linear differential equation, that also in just 3 steps. The 3 steps to solve a first order linear differential equation are given over here. It will be very clear as we take an example. Also, one more thing before we start. You can also have a linear differential equation of first order of the type dx by dy plus p1x is equal to q1, where your p1 and q1 are either constants or function of y. So that is also possible. This is another representation of first order linear differential equation. Only difference is between the independent and dependent variables. So the 3 steps. In the first step, just compare your equation with dy by dx plus py is equal to q form. Then find a term called integrating factor, which is nothing but e raised to integral p dx. Third step, multiply y by the integrating factor, and on the right hand side you will have integral of q into integrating factor plus the constant c. These are the 3 steps. Let us straight away start with the example. First example, find the general solution of the differential equation dy by dx minus y is equal to cos x. So now if you compare with dy by dx plus py is equal to q, what is your p? P is minus 1 and q is cos x. Second step, find integrating factor, which is e raised to integral p dx, means e raised to minus 1 dx, which is nothing but e raised to minus x. Third step, actually why we are doing y into integrating factor, this I have just demonstrated in the first example. Otherwise, you just need to multiply y by the integrating factor on the left hand side. So basically, when you multiply integrating factor on both the sides, it will be e raised to minus x dy by dx minus e raised to minus x into y is equal to e raised to minus x cos x. If you check it out, the left hand side is a derivative of y into e raised to minus x. That is the reason I told you in step 3, you just have to multiply y with the integrating factor. So in step 3, left hand side is y into integrating factor, which is e raised to minus x over here, is equal to integral of q. What was q? Cos x into integrating factor e raised to minus x. You have to find this integral plus the constant c. So now suppose I is integral e raised to minus x cos x dx. Then let us first of all find this integral. Okay. So just use the multiplication rule. Integral u v dx is equal to u into integral v dx minus integral du by dx integral v dx whole dx. Take u as cos x and v as e raised to minus x. So now it's just simple. U means cos x into integral of e raised to minus x is minus e raised to minus x. Similarly, minus integral of e raised to minus x upon minus 1 into derivative of cos x, which is minus sin x. Now find this integral. See here, the steps for differential equation solution are over, but we just need to simplify this integral I. So our I is minus e raised to minus x cos x minus integral of e raised to minus x sin x. Again for e raised to minus x sin x, apply the integral u into v rule. So now afterwards when you simplify that, you will be getting I is equal to e raised to minus x into bracket sin x minus cos x. So what is I? I is sin x minus cos x into e raised to minus x upon 2. Now just substitute your value of I in our equation, which was y is e raised to minus x is equal to sin x minus cos x upon 2 e raised to minus x, which is our I, plus c. So you have obtained the general solution. For getting the general solution, on left hand side you need just y. So just divide the right hand side by e raised to minus x. So the answer is, the general solution of the given equation is y is equal to sin x minus cos x upon 2 plus c into e raised to x. Next example, find the general solution of x dy by dx plus 2y is equal to x square log x. Now first step, as it is, compare with dy by dx plus py is equal to q. So dy by dx, now divide the equation by x. So dy by dx plus 2y by x is equal to x log x. So what is your p? P is 2 upon x, q is x into log x. P and q are functions of x, as you know. Second step, integrating factor is e raised to integral p dx. So e raised to integral of 2 upon x dx. You know 1 upon x integral is log mod x. So e raised to 2 log mod x. Or log means over here, remember it is log with the base e. So you can also write ln. Now there is a rule for log. Ln of a raised to x is x into ln of a. So e raised to 2 log mod x is log mod x square. What is that? E raised to log. Exponential, logarithmic are inverse functions. So e raised to log will be x square. So integrating factor is x square. This was the second step. Third step, y into integrating factor is integral q into if dx plus c. So in this example, integrating factor we found it is x square, q is x log x. Put the values. X square into y is equal to integral of, here q is x log x into x square, means x cube log x. Now this integral x cube log x, again use the multiplication rule. Now remember, in using the multiplication rule, take care which function to take as u and v, so that the simplification becomes easy. Here you need to take u as log x. U is a function generally whose derivative you can easily find out, and v is a function whose integral you know. So over here it is log x into integral of x cube, which is x raised to 4 by 4, minus integral of du, derivative of log x is 1 upon x into x raised to 4 by 4. So now when you simplify it, you get x raised to 4 upon 4 log x minus x raised to 4 upon 16. Now our equation was x square into y is equal to I plus c, and I value we just now found out, it is x raised to 4 upon 4 log x minus x raised to 4 upon 16. Substitute this value. Now on the left hand side, again as I told you, just want y, so divide by x square. So finally what will you get? Y is equal to x square by 16 into bracket 4 log mod x minus 1 plus c into x raised to minus 2. This will be your general solution. Next example, see we are doing different type of examples, but the three steps that will remain the same. So now in this example, first of all, convert your equation in the form dy by dx plus py is equal to q. So obviously we need to divide by 1 plus x square. So now what you get is p is equal to 2x upon 1 plus x square, and q is cot x upon 1 plus x square. Again note that p and q are functions of x. Integrating factor e raised to integral p dx, e raised to integral 2x upon 1 plus x square dx. Now see, this integral As I told you in integration, if you see the video on integration, three rules are there in integration. One of the rule is this one: integral of f dash of x upon fx dx is log mod fx plus c. This becomes very handy when you need to solve complex examples. So here if you see, it is very clear, 2x upon 1 plus x square. So if you take your function fx as 1 plus x square, its derivative is 2x. So directly the integral is log mod fx, means log mod 1 plus x square. Also, if you don't want to do this, you can substitute x square as t and you will be getting the same answer. But this rule gives you directly the answer in a second. So your integrating factor is e raised to log, or log with the base e means ln, mod of 1 plus x square. But now again you know that e and log, they are inverse functions. So e raised to log of something is the same term. So you get e raised to log 1 plus x square is same as 1 plus x square. And mod I can take out because it will be positive. So what is the third step? Y into integrating factor on the left hand side means 1 plus x square into y. Right hand side integral of q. Q is over here cot x upon 1 plus x square into integrating factor 1 plus x square. So 1 plus x square gets out, cancelled. So integral cot x dx plus c. You know integral of cot x, it is log of mod sine x. So log of mod sine x, but log with the base e, so that you can also write as ln. Both are same. So 1 plus x square into y is equal to log mod sine x plus c. Again, you need y on the left hand side, so divide the equation by 1 plus x square. So your final answer is y is equal to 1 plus x square raised to minus 1, or 1 upon 1 plus x square into log mod sine x plus c into 1 plus x square raised to minus 1, or c upon 1 plus x square. Next example, find general solution of y dx plus x minus y square into dy is equal to 0. Now this, if you want to convert in the form of dy by dx plus py is equal to q, where p and q should necessarily be functions of x, then it will not be possible. You can check it out, correct? So in this case, we are going to use another form of the differential equation. I said previously, you can also have a differential equation of the form, only the independent dependent variables change, of the form dx upon dy plus some p1x is equal to some q1, where over here p1 and q1 will be functions of y, correct? So now what will happen is, if you convert in the form dx by dy, you will get dx by dy is equal to minus x minus y square upon y, or dx upon dy plus x upon y is equal to y. So now if we take p1 is equal to 1 upon y and q1 as y, then your p1 and q1 have now become functions in y. So here we are comparing with the form dx upon dy plus p1x is equal to q1, where p1 and q1 are functions in y. Steps to solve the differential equation will remain the same, only interchange your x and y variables. Second step, integrating factor over here will be e raised to integral p1 dy. So in integral of 1 upon y dy, you know it is log y. So again e raised to log y means just y. Now third step, x into integrating factor means x into y is equal to q1. What was q1? It was y. Into integrating factor is also y over here. So integral of y square dy plus c. So now you get this as y cube by 3 plus c. Here you want x. Remember, x and y variables are interchanged. So you want x on the left hand side. So divide the whole equation by y. We get the general solution as x is equal to y square upon 3 plus c upon y. Next example, you know that you can also find particular solution of a differential equation by finding the value of constant c. So in the next example, if you see, you need to find the equation of a curve which passes through the point 0, 2. Means the boundary conditions, or the conditions for the equation are given, which is y is 2 when x is 0. Second thing, to get the equation, what is the condition given? Sum of the coordinates of any point. Suppose xy is any point. Sum of the coordinates will be x plus y. It exceeds the magnitude of slope. Slope given by dy by dx by 5 means x plus y is equal to dy by dx plus 5. This is our differential equation. Now first step, convert in the form dy by dx plus py is equal to q. So p is minus 1, q is x minus 5. Integrating factor e raised to integral p dx, e raised to integral minus 1 dx is e raised to minus x. So the integrating factor over here is e raised to minus x. Now, for the third step, y into integrating factor is equal to integral q into integrating factor dx plus c. So, y into e raised to minus x is equal to, what was your q? X minus 5 into e raised to minus x. Now, let I be integral e raised to minus x into x minus 5 dx. Use the multiplication rule, but again I am telling you, take care while choosing your functions u and v. So over here, choose your function u as x minus 5 and v as e raised to minus x. Put the values, you will be getting that integral as minus of x minus 5 into e raised to minus x plus e raised to minus x upon minus 1 plus c when you simplify it. Again, next step, simplify it. So you will be getting, simplify it and divide by e raised to minus x because you want y on the left hand side. So you will be getting y is equal to 5 minus x minus 1 upon, plus c upon e raised to minus x. So 4 minus x plus c upon minus x. So your general solution is y is equal to 4 minus x plus c upon e raised to minus x. For getting the particular solution, put y is equal to 2, x is equal to 0. So you will get the value of c as minus 2. So the particular solution to the given question is y is equal to 4 minus x minus 2 upon e raised to minus x. One more example to find particular solution. Dy by dx plus 2y tan x is equal to sin x when y is equal to 0, when x is equal to pi by 3. This is the condition given. So you have to find the particular solution. Steps are same. When you compare with dy by dx plus py is equal to q, your p is 2 tan x and q is sin x. Integrating factor e raised to integral 2 tan x. You know integral of tan is minus log mod cos x. So again integrating factor e raised to minus 2 log mod cos x means minus of log mod cos x square or cos raised to minus 2. So again e and log inverse functions. So what is your integrating factor? It will become 1 upon cos square x or sec square x. Now next step, y into sec square x means y into integrating factor is equal to integral of q into if. Q is sin x into 1 upon cos square. You can write that as sec x tan x, and integral of sec x tan x is sec x. So, and after that you divide by sec square x. So what is your general solution? Y is equal to 1 upon sec x plus c upon sec square x. Or when you simplify it, you can write it as cos x plus cos square x into c. Now the condition, put y is equal to 0 and x as pi by 3. Cos pi by 3 is half, cos square pi by 3 is 1 upon 4. So c is minus 2. So what is the particular solution? Particular solution for x is equal to pi by 3, y is equal to 0 is y is equal to cos x minus 2 cos square x. So, as I told you, solution of linear differential equation follows in just 3 steps. In case of any query with any of the examples, you can write in the comment section. Do like and share the video and subscribe to the channel.